also in this cell we just introduced. So yeah, we also loaded that data set into a data frame. Df is the data frame, and pd dot data frame iris dot data, and columns iris dot feature names. So feature names, these are the feature names that were the column names that we'd already explored, that it was available in the dataset description. Just let us take a look at that also. So here in the dataset description, we see that there are feature names, and these are the 4 columns of our data frame that we just loaded here. So iris.data and that array that's loaded here, these are the feature names that becomes the column names for our data frame. And then we also introduced another column, df target, which is iris.target. So it just adds a 0 and a 1 for all these uh, columns, all these rows. Then this was the shape, and we explored that there are 150 unique rows in this data set, and all the rows are divided into 3 parts of 50 each into all the 3 categories: setosa, versicolor, and which is the third category, virginica. So these are the 3 flower categories, iris plants data set. These are the plants that we're exploring. So there are 50 values for each of them. Then we just also take a look at the targets 1 and 2. After that, we're also including a flower names column inside the data frame, which is defined using this lambda function. So what we do is we take the target column, and then we just name that using the flower names using this lambda function. I hope we get that, because this dot target names x, this target names is also available in the dataset description. So if we just take a look at this target names, this is also available as an array. So we just indexing that array using this x here inside that lambda function. So if the target is 0, if this df dot target column gives a value of 0, then this would be setosa. If this is 1, then it would be versicolor, and if this is 2, for example, right here it is 2, it would be virginica. So that's how we formed this df flower names column. Then also create a dictionary for that. So 0 is for setosa, 1 versicolor, and so on. Now we'll explore examining the data, how to examine the data that we've loaded. So to examine this data, first of all, what we do is we just separate our data into x and y values, because we have to train our model on x and y. So we just load our data frame columns that we'd already loaded into the x variable, and also the target column of the data frame into the y variable. So this is the scatter matrix that we print right here. So for a scatter matrix, you have to provide a data frame that it does prints. So pd dot plotting dot scatter matrix. So what does the scatter matrix require? It requires a data frame that has to be plotted. These are all not necessary values, but we still provide that because we just wanted a fixed figure size so that we are able to analyze it in a better manner. I think I just reduce that to 8 by 6, then it would all come in a single frame and we'll not have to scroll again and again. So yes, so now it's all in a single frame right here. Okay, let's take a look at that. Okay, yeah, first of all, I'm just exploring the parameters that we've provided inside the scatter matrix. So this is the data frame that we've provided x. This x variable is this x variable contains these columns, these 4 columns of the data frame, and y is obviously the target. So to separate the 3 targets, I just set a color parameter here, and that is equal to y. So it is either 0, 1, 2. So just separates these into 3 different colors. So for example, you can just take a look at that here. It is either yellow or purple or a greenish color right here. And this is just the third, which is the figure size, which we just explored. So what does the scatter matrix do? It plots that columns of the data frame that it took here as an input, and it just plots that into this grid kind of a thing. So all the 4 columns are here as well as here. All the 4 columns are present on both the axes of the matrix, and it just plots them. So for example, if we take a sepal length and a petal width, so it is just plotting all of them, and it shows that okay, this color has them here, this target has this integration or correlation in between petal width and sepal length, and similarly sepal width and petal width and petal length and petal width, and this fourth column all has a petal width and again petal width. So this is just a histogram of these two, because it just has the same values on both of the axes. Similarly, we just plot all of that, and we can just see that okay, we can choose some of the features from here to separate these values. So here you see you can separate the 3 targets using this petal width and sepal length, but it would be quite difficult to separate using sepal length and sepal width, because here the green and yellow values are really close. Similarly is the case with sepal width and sepal length. I guess we just consider that yes. So just yeah, really mingled. And here also I think we can separate them easily in the petal width and petal length. because they're not. Yeah, the purple ones are completely different from the green and yellow in this case, and also there is a separate line, thin line between yellow and green as well. So yeah, I think sepal width should not be considered because in most of the cases, these two are the yeah, yellow and green ones are quite closely related. Rest we'll see. Then we also separate the data frame into three different data frames: data frame 0, 1, and 2. So we are already seen that there are 150 values in the 150 rows in the data frame, and those three are also divided into three parts, 50 rows for each of the target value, Virginica, Sedosa, or versicolor. So I just separated that into three data frames: df0, df1, df2 for all the three targets. Just run this. So this is df2. Now it only contains Virginica. If I take a look at df0, then it is just Sedosa. Yes, and if I take a look at the F1, then it is just versicolor. So now what we do is we just plot all three of them. So axis, we just did a scatter plot for all three of them and separated them using colors, three different colors for three of them. So the sepal length and sepal width are considered. Sepal width and sepal length. But they were very closely related. How did we use? Okay, I think I was just exploring that. Okay, so I just did a scatter plot of DF. Okay, so this is a way of plotting pandas data frames. You just do a df dot plot, and then whatever plot you want here. It can either be a bar plot or a line plot or anything that you want. So, oh, it was showing what all to be included here. So it should contain, the parameters should contain an x value, a y value, uh, a color, and this I think is size. I think let's take a look at that. String, scalar, or array like size of each point, and this is the color. So these are the four inputs. We've just given three of them, which is sepal length, sepal width, and what is the x-axis, the y-axis, and the color. Now I just defined that into this axis ax, and I did a similar kind of plotting for df1 and df2 as well. So just did plot scatter, and axis is common for all three of them. So the colors are different: green, blue, and red. And I just plotted that. So let's take a look at this. So these are the three target values that I have. This is the first one, Setosa. It is green in color. Then versicolor, blue in color, and this was Virginica, and that is red color. Now let's use our KNN, K-nearest neighbors model for classification. Now, first of all, what we need to do is train test split. So we'll just explore this in the next video. It is a lot of noise. It just ends here. Next is the digit classification, which I think is for regression. No, classification, sorry. That's the digit classification itself with the name it says. Okay, and after that we have regression. There's a lot of stuff coming up using KNN. We'll just cover that in the upcoming videos. KNN. Okay, because it is becoming a very long video. It is already, I think, 13 minutes. No, 14 minutes long. So I just stop right here. Okay, let's just take a look at this as well. Let's just take 1 minute more. Train test split. So train test split is while performing predictions or classifications on our data set, we just split the data set into train and test data. What is that? So when you perform a prediction or anything, when you try to fit your model to your data set, it becomes used to that data set, and we do not know if it is actually performing good on an unknown data set, or it has picked those values from the already fed into data set, and it is just giving the correct answers for that. So for that, we just split our data into train and test in order to test the data set on some unknown values. So to do that, it is a very simple function, and it is a train test split function which we exported in our first cell right here from sklearn.model selection import train test split. This is the one function that we imported here in the first cell. And now, how to use this? So default split is 75-25. So the trained data is 75% of the complete data set, and 25% of the data from the data set becomes the test data. Now, to use that, I just write x train, x test, y train, y test, and use this function train test split, in which I would pass my x values, my y values, and this is a random state. So let's explore. I know what random state is, but I just want you to explore it using this, because it has to be, because you need to now know how to use these already defined things that they provide in here. So let's take a look at this. Okay, just a second. What I would do is see now Oh my god, what is happening here? Okay, so I have this test size, test range. These are the arrays that we already provided, X and Y dataset, and this is the test size. I can change the test size. I can just explore many other options using this train test split function, but and random state. Here it is written. Oh my god, it does a lot of creates a lot of problems sometimes, I guess. Yes, please do not do that. Okay, random state. So it would be given here. Let's take a look at that. Random state instance or none controls the shuffling applied to the data before applying the split. Pass an int for reproducible results. So random state is you can just shuffle the data set before applying this train test split. But I do not want any randomness when uh, splitting this data, because I think if I want to perform again this train test split again, then I should have the similar kind of results. But you can explore this option and pass any other integer here. Then okay, just run this cell. So we have split. That's it. This easy. It was this easy to do it. So it's just train, test, and y train and y test. That's it. Now I would just. This is the most important part. I would just load my k-nearest neighbor classifier into this variable KNN. And again, this is also very easy to do. Again, from sklearn.neighbors, I would just import k neighbors classifier. That's it. That was the complete video about this is the thing. This line from sklearn.neighbors import k neighbors classifier. That's it. This is the classifier that we built, and we just customize it according to our needs. So here I just set neighbors as 7. I can again change this to 3 to 5 to any number of integers I want to change. So that is it. Let's load that. Now this is training the classifier. KNN dot fit operator is used, and we just pass in the X train and Y train, and it returns this kind of a cell which says, okay, you've trained using 7 neighbors. Now we'll just estimate the accuracy. Dot score is used for that. Now it is 97%. But let's try this using 3 neighbors. 3 neighbors here. So now KNN should train using 3 neighbors. Here it says, okay, 3 neighbors have trained using 3. And again, 97% accuracy I have. Now prediction and confusion matrix. Now let's predict some values using that. So I just passed one of the data entries which is present in our first cell again. So star name predict. So I just the star name was a dictionary, and I just passed in this prediction.